We are doing 11-6 infinite geometric series. So if you remember that an infinite series in general just means that it's a series that keeps going and going and going and going, and you're adding them together all the time. It goes on forever. It's infinite. It doesn't stop. There is a way to find the sum of an infinite geometric series, which I know sounds weird because you're adding numbers forever for eternity. How could you possibly actually come up with a sum? However, if the number, like if your ratio is less than 1, eventually it's going to slowly get closer to 0, and it will in fact just like stop. So if that's the case, then you can actually find the geometric infinite geometric sum. So for example, well, first let me give you a formula. You have S equals T1 over 1 minus R, but like I said, the absolute value of R has to be less than 1 in order for this to work, because it's going to get closer and closer to 0, and it'll approximate to 0 in the end. So, for example, if I gave you, let me do A, 8 minus 4 plus 2 minus 1 plus ... The first thing you want to do, since you know you're finding the sum of the geometric infinite series, is to make sure that the absolute value of its ratio is less than 1. So we know that R is negative 4 divided by 8, which is going to be negative 1/2. So you look and go, okay, is the absolute value of negative 1/2 less than 1? So is 1/2 less than 1? Yes. If it is, then you can go ahead and use the formula. So I'll have S equals my first term, which is 8, over 1 minus negative 1/2. So I'm going to have 8 over 1 plus 1/2. So I really have 8 over 3/2. Take the reciprocal and multiply, you have 2/3. 8 times 2 is 16 over 3. So your answer for your sum is 16 over 3. Let's do another one. Let's look at B. What if I gave you 8 plus 12 plus 18 plus 27 plus ... So 12 divided by 8, you know that 4 goes into both of them. So 4 goes into 12 3 times, and 4 goes into 8 twice. So we have to check to make sure that R is less than 1. So is 3/2 less than 1? The answer is no, because that's 1 1/2, and that's not less than 1. So your answer would be no sum, because you can't figure it out, because this one is not getting closer to 0, it's just increasing. Example number 2. It says write 0.121212 ... as a common fraction. So basically what that means is, you know that this 12121212 is repeating forever. So you want to break it down with the repeating part. So the first one is just 1.2. If I want to get the next 1.2, I can add 0.0012. And if I add these two together, I would just have 1212. The next one would be 0, 0, 0, 0. There's 4, 1, 2. And it would keep going on forever like that, and you would have to move the decimal point over twice every time to make sure that you were getting your 12s to be in the right spot. So I have 2 spots here because I have 2 spots here. I have 4 spots here because I have 4 numbers here, and I have to get the next one too. So what you can do is you can see, first of all, if r is less than 1 and see if this series has a sum, okay? So the reason you would find the sum of this is because you're trying to find what it is as a fraction. And this is a repeating decimal, so we know it has a fraction. But let's double check. You would look at 12.0012 divided by 0.12, which is 0.01. And the absolute value of that is less than 1, so we know that this is going to work. So we'll use our formula. Our first term is 1.2. 1 minus 0.01 on the bottom. So I have 0.12 over 1 minus 0.01 is 0.99. And when you look here, if you want, you can move your decimal points over twice so that you're looking at 12 over 99. And you know that 3 goes into both of those. 3 goes into 12 4 times, and 3 goes into 99 33 times. So I have 4 over 33 as my common fraction, and I use series in order to find this.